Thanks, Todd. So as Todd was saying, I'm going to talk about nitrogen management for the last presentation today. I'm going to cover a few topics. One of the topics that I'd like to cover is nitrogen management in field corn following sugar beets, as well as our nitrogen rate trials from 2020, and then a compiled data set going from 2010 to 2020. So first, I'm going to talk about nitrogen management for corn grown after sugar beets. So the purpose behind this trial is to look at how nitrogen management might differ if we go into a field that has beets that were not harvested compared to beets that were harvested normally. Situations that might cause this, the beets being frozen out in the field and not able to be harvested, or if there was a set aside. So for this trial, we planted beets in 2019, and in the end of the season, we harvested some of those plots. We harvested all 6 rows of the 6-row plots and removed them from the field, and then we left some of the plots unharvested. However, they were topped and defoliated. In 2020, we planted field corn on May 1st at a 34,000 population. Some of these treatments received a starter of 7 gallons of 1034O plus 1 pound of zinc, and some of the treatments did not receive a starter. We had spring applied urea incorporated with a field cultivator, and the trials were machine harvested on November 4th by the University of Minnesota. You can see here in this picture on the left some beet carcasses left at the end of the season, even in 2020. Here's some drone images taken on July 15th. This trial was set up as a randomized complete block design with 9 treatments and 4 reps. You can see 3 of the reps here in this picture. We did have some untreated checks in this trial to see response to nitrogen. You can see those here, slightly lighter green color. And over here, you can also see that we had some height differences between some of these treatments as well, even though there may not have been a color difference between them. So as I said, we had 9 treatments in this trial. Some of the beets were not harvested. So treatments 1 through 6, the beets were left in the field. Treatments 7 through 9, the beets were harvested and removed from the field. Treatments 1 and treatment 8 did not receive a starter. This was to see a response to starter compared to beets that were not harvested versus beets that were harvested. We used nitrogen rates based off Minnesota recommendation, University of Minnesota recommendations. The recommended nitrogen rate would be 155 pounds of nitrogen. Off of that recommendation, we did use a lower rate. We reduced that 40 pounds per acre for treatment 3. We increased it 40 pounds for treatment 5 to 195, and we increased it 80 pounds for treatment 6 up to 235 pounds. So those were all for the non-harvested sugar beets, and then we had a harvested plot that used the recommended rate only. These were the yield differences that we saw in this trial. So if we look at the starter plots first, we see that without a starter, we had 107 bushels for this treatment. If we added a starter, we increased that significantly with the beets that were not harvested. However, we did not see a difference using starter or not using starter if the beets were harvested. With the recommended nitrogen rate on not harvested beets, we had a total yield of 234 bushels. So that's a decent yield. However, when we added 40 pounds of nitrogen, we increased our yield by 21 bushels. However, if you look at the next 2 treatments, adding an additional 80 pounds did not increase our yield over that additional 40 pounds. And at the recommended rate on the harvested beet plots, we had the same yield as the additional 40 pounds required for the non-harvested beet plots. Now this is 1 year of data. However, we do see from this 1 year of data that a starter is beneficial if the beets are not harvested. And having additional nitrogen is also beneficial to our yield if the beets are not harvested. We have a trial set up to be conducted in the spring of 2021. We removed the beets here already in the fall of 2020. So once we have a few more years of data, we will hopefully be able to have a more solid recommendations for growers if there happen to be any beets left in the field. So moving on from field corn into our 2020 nitrogen rate trials for sugar beets. I have 2 trial sites that I'm going to talk about today. The first trial being at the Blomkist location. This is a drone image taken on June 24th. You can see that we have 6 reps in this trial, and this is set up as a randomized complete block design, and with a total of 10 treatments. In this image, you can see some differences in canopy if you compare this plot here to the one to the left. So we have some more row closure between some of these treatments, and also you can potentially see some slight differences in canopy color as well. The treatments in this trial were applied as spring urea and incorporated using a field cultivator. The trial was planted on April 25th, and we used regular best management practices to keep the trial weed and disease free. This picture here is our research lifter. These plots are 6 rows wide, and we lift the center 2 rows in each plot for our yield and quality analysis. From the center 2 plots, we take 20 pounds for our sample to bring to the lab for analysis. This particular trial was harvested on October 14th. For this trial, we did have a total of 10 treatments. There's 2 purposes to this trial. One of them was to look at a nitrogen rate response, and the other was to look at a split application. So I'm going to speak on the nitrogen rate response first. We had a soil sample 0 to 4 feet, and for a total of 43 pounds of nitrogen. So our first treatment is a total of 43 pounds with 0 nitrogen applied in the spring, and we applied rates of 20, 50, 80, 110, and 140, up to a total of 183 pounds of total nitrogen, soil residual plus applied. If we look at the yield for this trial site, you can see that we had very high yields. We had 40 tons per acre just with the residual nitrogen with no nitrogen applied, and that did not significantly increase with increasing nitrogen rates. So we did not have a response to nitrogen at this trial site. We can see similar results for the extractable sugar per acre. We had over 12,000 pounds of ESA for all of these treatments. We did see a slightly significant increase in extractable sugar per ton, however, with these treatments. So this site overall was non-responsive to nitrogen. Just sharing a couple of pictures here as a visual aid. These pictures were taken in early July. You can see this picture here is the 43 pounds of total nitrogen. At this time in the season, we did not have full row closure. We're getting close, and you can see, if you look closely, there are a couple water hemp seedlings here that I took a picture of before they were pulled from the plot. The next picture is of the 153 pounds of total nitrogen. So you can see a much denser, thick interwoven canopy. However, these visual differences that we saw in these plots did not equate to a yield difference at the end of the season. The second part of this trial that I will speak on, I think Dr. Melissa Wilson got a question about split applied nitrogen, and hopefully this will try to answer that question. In this trial, we had 2 different rates for our pre-plant treatment. We had 50 pounds of nitrogen applied and 80 pounds of nitrogen applied with 0 applied in season. With the residual nitrogen that was there, that total would be 93 pounds and 123 pounds. We split those rates, 25 and 25, 40 and 40, and then we also had 0 applied pre-plant, and then those totals 50 and 80 applied in the season. The split nitrogen was applied on May 26th, approximately 4 to 6 leaf beets using 32% with a coulter. So again, we did not have a response to nitrogen for the trial site, so we did not expect to see a difference in the split applications for this trial. We had an average of 41.2 tons per acre for these treatments. We did not have a significant difference in purity or ESA, and not much of a difference between these particular treatments for EST. However, we've done this trial for a number of years now. We have a total of 5 trial sites for this particular comparison. Out of those 5 trial sites, 2 of them were responsive to nitrogen. And in those 2 trial sites, we did not see a significant difference between those for nitrogen, for root yield or ESA. So there's not a negative or positive benefit to having the nitrogen applied pre or applying it as a split application. However, there is risk management involved there. If you miss your window for applying your split nitrogen, that could have a detrimental impact on your yield. The second site that I'm going to talk about today is our Wood Lake location. This is another drone image taken on June 23rd. This trial site, we worked with Dr. Dan Kaiser for this trial. It is not set up as a randomized complete block design, but a strip plot design. So you can see that there are treatment differences in canopy here. They're in blocks of 3. So you can see that there's a significant difference here in the canopy between some of these blocks compared to the ones next to them. The treatments in this trial, again, were applied as spring urea and incorporated using a field cultivator. This trial was planted on April 22nd. Again, regular best management practices were used to keep the trial weed and disease free, and it was harvested on October 15th. For the Wood Lake location, we did not have the same nitrogen rates applied, a slightly different trial. However, we had a soil residual nitrogen test that was very low again. This trial site had a 30-pound residual from a 0 to 4 foot sample. We went with that check, so a total of 30 pounds with 0 applied, and we went up in increments of 30 pounds, all the way up to 210 pounds applied, for a total of 240 pounds of total nitrogen. So at this site, we did see a response to additional nitrogen. You can see for our check at 30 pounds of total nitrogen, we had 29 ton almost for our root yield. That is a decent amount of tons per acre for 30 pounds of total nitrogen. However, we did see an increase going all the way up to 240 pounds of total nitrogen applied for approximately 41 tons per acre. We also saw a significant increase in EST, and as expected, we saw a significant increase in ESA from 8,500 pounds all the way up to 12,000 pounds at the highest rate. A couple pictures to go along with those treatments. So this is the 60 pounds of total nitrogen. You can see that we do not have as much row closure as we did at the previous location, with quite a bit of space left between the rows here in early July. Compared to another treatment at 210 pounds of total nitrogen, this is quite a thick, robust canopy in comparison to the previous picture. So, quite the difference in response to nitrogen within 1 year. So I just want to talk about these 2 trial sites a little bit. The site that we just talked about at Wood Lake, the previous crop was field corn. The organic matter was 4.5%. And the soil sample from fall to spring, we took 2 samples. The fall sample was 43 pounds and the spring was 30 pounds of total nitrogen from 0 to 4 feet. So we did see a little bit of a reduction. Now that could have simply been sampling error. 13 pounds is not a huge difference. However, it could also be that we had more nitrogen being tied up in the corn residue as well from fall to spring. The Blomkist location, the previous crop was soybean, organic matter 5.4%, so almost a 1-point difference in organic matter. And the soil sample from fall to spring, 43 pounds to 44 pounds, so pretty much identical from the fall to spring soil sample at that location. So we have differences between these two trial sites in the previous crop, field corn and soybean, difference in organic matter between the two sites, as well as residual nitrogen. So these are some of the differences that may play a role in the differences that we saw in response to nitrogen at these two locations. However, that probably does not encompass the reason we saw this difference in its entirety. So within 1 year, we see significant differences in our responses to nitrogen, looking at two different sites. And this is very similar to what we see looking at our compiled nitrogen data set from 2010 to 2020. We have a total of 19 trial sites in this time span. Out of those 19, we had 10 responsive and 9 non-responsive sites. So when I talk about responsive and non-responsive, what I mean is that we had a response to nitrogen or additional nitrogen, right? So a responsive site, an example of that would be the Wood Lake location that we just covered. And it may be a positive linear response like Wood Lake, or it could be a quadratic response to nitrogen or a negative linear response to nitrogen. Non-responsive site, an example of that would be the Blomkist location from 2020, where we do not see a negative or positive impact from additional nitrogen. So almost half of the years did not respond to additional nitrogen. Over 70% of these trials were following field corn, and all of the treatments were applied using urea in the spring. So if we look at this graph, we're looking at extractable sugar per acre, the pounds per acre on the y-axis. The x-axis is soil test nitrogen plus fertilizer applied, so this is total nitrogen available in that treatment. So if we look at this line, we can see it's a quadratic response over an average of all these years. And we can see that the peak is here, around 130 pounds of nitrogen per acre. And we can see that at the peak here, it's a fairly flat quadratic here at the top. So between 110 and 150 pounds, that's the area in which you would see your optimal return for applying nitrogen as far as ESA. Now there's two factors to achieve optimal ESA. One of them is tons and the other one is quality. Now in a year like 2020, where we have maxed out our ability to run the factory on 3.6 million tons, the only way to improve the yield or the amount of output of sugar out of the factory is to improve the quality of our beets to increase the sugar content or purity. So that's the only way to improve ESA after we've already maxed out our tons. So that range that we're talking about, 110 to 150 pounds, it appears that on average, that is where we need to be for our total nitrogen to have optimal ESA production. I just want to talk about a few things that we've been in discussion about that might impact where we are at in that 110 to 150. The research staff, along with the Shareholder Innovation Committee, has been in a lot of discussions about how we can best manage nitrogen in this range. So 110, we would consider the floor of that range. We want to make sure that all of our field is above 110 pounds. As you can see, when we get below that, we tend to see a reduction in our yield. Just a reminder, 130 pounds is the peak of that curve. So if we're somewhere between that 110 to 150, on average, we should be able to have optimal return for ESA in that field. Now, having the total nitrogen in the correct range depends a lot upon having a residual nitrogen test, a deep soil test. Now, our plots are very small. We can get a very accurate soil test in that small area. Grower fields are much larger, obviously, and we can see a lot of variability in those fields. So we need to make sure we have multiple tests across the field so we get an accurate soil test and we can get within that nitrogen range. There are other factors to take into consideration when we're looking at how to manage our nitrogen within that range. Previous crop. So we talked about that a little bit already with our 2020 trials. There may be a difference in residue and nitrogen tie-up between field corn and soybean and other previous crops. We do have a project in 2021 to 2022 that will be looking at rotational crops. We have a trial that will look at field corn, soybeans, sweet corn, and wheat, as well as some different nitrogen rates. Residue management, that kind of goes in hand in hand with the previous crop. However, what I mean by residue management is how well was our residue incorporated. So in a year where it's wet in the fall and we don't get good incorporation, we have different residue breakdown compared to if we have a nice fall and we are able to get that residue incorporated. Also the type of tillage, if you're able to get aggressive tillage done and bury the residue compared to if you run a minimum tillage system, your nitrogen requirements might be slightly different. Fall versus spring application. There is always the potential for nitrogen loss over the winter. This is really dependent on the weather, but there's always that possibility. So your requirement might be slightly different between fall and spring. We have a project currently in place with Dr. Dan Kaiser. We have the fall applications out for 2020, and we'll put on the spring treatments in 2021. We've talked about organic matter a little bit already as it relates to the 2020 trials. There is a difference in mineralization potential between a field that has a 4% organic matter compared to a 6% organic matter. Now this is very dependent on the weather again. If we have a dry season, we may not get that mineralization, or if we have a wet season, we will get that mineralization. Also, manure history. Depending on the field, if you have had manure applied in the past, you may have a nitrogen credit. Dr. Melissa Wilson has already covered the project that we currently have in place, and we hope to be able to bring that data to you in the near future following its completion in 2022. So again, there are a lot of different factors that that you need to take into consideration when we're looking at these nitrogen recommendations. On average, this is the best nitrogen management recommendations that we have is 110 to 150 based on all the data sets that we have. Within that range, we would like you to take into consideration these different factors, which may put you toward the bottom of the range or the top of this range. We will be looking into a lot of these factors in the future, and we hope to have a more encompassing recommendation in the future based on some of these factors. One thing I'd like to talk a little bit about is grower strip trials. We can do a lot of research here in small plots, but we can't do everything. It's great for growers to get out and look at these different things on their own field and their own farm. You're very familiar with the variety strip trials. We've also done strip trials with growers with Cercospora leaf spot. And we've also just helped growers and assisted them with answering questions on how to conduct these trials, as well as helping them to analyze the data at the end of the season. So I'd just like to cover one example here to share with everyone. This is an example of a grower strip trial that he did with in-furrow products and also a foliar nutrient comparison. So we have 3 treatments, blue, red, and green here, and that was replicated 6 times across the field. So you have 18 different strips here. So we had 2 in-furrow products and then a check with no in-furrow product. In addition to that, this operation also put on a foliar nutrient product 4 times in a CLS application across 3 of those strips. So you really had 6 treatments with 3 reps. So in this operation, they did a great job of having these treatments applied, as well as collecting a lot of quality samples at a total of 108 quality samples and 54 yield samples. So it is a lot of work conducting this type of trial. However, they did a great job. They did see in the analysis there was a numerical benefit to adding a starter. We do tend to see that in our research. We have a response to adding a phosphorus starter in the spring with sugar beets. However, they did not see a response to the foliar product in this particular trial. So I just want to share this as an example of what some growers are doing out in the country, and I'd like to thank Lucian and Noble Farms for sharing this example with us. And I'd like to encourage any other growers that are interested in conducting strip trials to reach out to your agriculturalist or someone on the research staff, and we're more than willing to help answer questions on how to conduct trials, as well as if you would like assistance with data analysis and getting the output from those trials. With that, if you are a certified crop advisor, now is your chance to scan this code with your mobile device to receive your CEU credits. I'd also like to take the time while you're doing that to acknowledge our cooperators. Dave and Kevin Shreen worked with us on the Wood Lake site. So I'd just like to thank them for working with us on those trials as well as with our OBT trials. The Youngkrantz brothers were our cooperators at the Blomkist location. So I'd like to thank them for working with us on that trial as well as our weed control trials. And to Brett Peterson for working with us on the corn following beets trial up in the Murdoch area. So a big thank you to all of our cooperators. Without them, this research is not possible. I'd also like to thank the University of Minnesota again for harvesting our corn trial, as well as for Dan Kaiser working with us on the Wood Lake trial and sharing that information with us. And a big special thank you to Dr. John Lamb for all of his help in setting up trials and data analysis over the years. So with that, I'd just like to wrap things up here. Thank you for your attendance and participation. Sorry. We'll answer a few questions first, I guess. I thought I was going to get away without doing that.
First question came in on a chat box. Do any of the nitrogen trials have previous year crop residue such as corn trash?
Do any of them have previous crop information?
Do any of our nitrogen trials were they conducted on previous crop corn and trash? Corn had been trashy residue on the corn. If you just want to address maybe how most of the trials have been.
Yeah, so as I said, for that 2010 to 2020 data set, over 70% of those were following field corn. In recent years, we also had several of them following field corn, and I will say that some of them were fairly trashy. Yes, so we have had trials in heavy corn residue situations in that data set.
The next question in the chat box was regarding the planting date and harvest date on those nitrogen trials. You could give us rough estimates of when both of those were.
Yeah, so we do try to leave our nitrogen trials to later in the season when the growers are harvesting during main harvest. We planted in late April. I believe it was 22nd through the 25th, depending on the trial site. And we harvested those two trials on October 14th and 15th. And that's very typical for when we try to harvest our fertility trials. We like to be during main harvest. I know we do harvest some of our other trial work before main harvest, and that's due to crop destruct samples that we don't want to run through the factory at that time. And those are generally they're usually disease trials and things like that. So the fertility trials are done during main harvest for yield.
On the corn following beets study, were the beets tilled in the ground first, or was it a no-till situation?
Right, so when we harvested the beets, the current recommendation right now is if you're going to leave beets out in the field, we're going to top and defoliate them, but we leave them in the ground so they can decompose better. So that's what was done in the fall. And then in the spring, when we applied the fertilizer in the spring, we did work those in with a field cultivator.
The last question in the Q&A is, please address the nitrogen removal rates with this 30-ton crop. And so, as you think on that, a couple things I guess I would say is, on the nitrogen removal rates or the nitrogen use for a sugar beet crop, we're returning some of that nitrogen back to the soil as we defoliate and we incorporate those tops. And I don't remember the factor on the root removal per ton, so I can't address that live here. I just don't remember that factor.
Yeah, that's a question we'll have to get back to you on. Is that all the questions?
That is all the questions.
Okay. So we'll work on getting the CEU QR codes put up here from any of the previous presentations in case you missed those. So take the time now to make sure you scan those to receive all your CCA-CEU credits. Thank you for your attendance and participation in our virtual production seminar today. These presentations will be made available on our website at some point. We will send out a notification when they are available. These research projects and many others are available in our annual research report, and that will be posted on the website at the end of January. If you have any questions regarding any of these presentations, feel free to reach out to someone on the ag staff or in the research department, and we will do our best to get any of those questions answered or put you in touch with the appropriate party.